You're baking muffins and warming dinner rolls. The rolls can go straight into the oven, but muffins need a pan, and there's only a limited number of them. Do you invest in more pans, add more ovens, or rethink the flow of work? There's a model for that. Welcome to Model Monday, a series where we break down scenarios in different industries, organizations, and departments, and explain how you can build a simulation of them in Process Playground. In this example, you'll see Part A and Part B, which are going to represent two different muffin recipes. Each one needs its own specific pan. For example, maybe you'll have large muffins and maybe you'll have mini muffins. Those pans are our fixtures. A fixture is a reusable, product-specific tool that has to be available before work can begin. Part C represents warming up bread rolls. They still are going to be in the oven, but they don't require a dedicated pan. In this model, we include fixtures to show what happens when a shared tool, such as a muffin pan, and not just people or machines, limit how work flows. Let's model it. So we're going to start with items. And we have a number of items that we need to create. First, we're going to create Part A, which maybe represents something like batter for our large muffins. Then we'll create Part B, which will represent the batter for our mini muffins. Now, both Parts A and B require a fixture, and in this case, different muffin pans. So we're going to put in Fixture A, which represents a large muffin pan, and then we'll create Fixture B, which represents the mini muffin pan. Next, we're going to create an order for both A and B. So this order requires that we bring together both parts as well as the fixture. So we're going to click on adding Part A, then we're going to add our Fixture A, and then we're going to click on this wait to pull for Fixture A. This way, our muffin pan is going to wait in our fixture rack until we have muffin batter available. We're going to do the same thing for Order B, where we'll add a Part B and a Fixture B, and then we'll click Wait to Pull. We're also going to have a third type of part that we produce that will be Part C, but it doesn't require a fixture. This can be like bread rolls that just need to be warmed up directly on the oven racks. So that's all of our parts. Now we need to create demand for these parts. So we're going to start with demand for A and B. We're setting this to an exponential distribution with a mean of 1 minute. That means on average about once a minute we'll get demand, but it could be a lot faster. We're going to do the same thing with Part B. It's an exponential with a mean of 1 minute. So now we've got our demand for parts A and B. The next step we're going to get into is kitting those parts with their respective fixtures. So I'll drag a kit block out here, and then I'm going to drag out this queue that represents our fixture rack. I'm going to turn off Allow All Items in this case, and I'm going to add Fixture A, representing our large muffin pan, and I'm going to say I have initial on hand of 2. Then I'm going to add Fixture B, our mini muffin pan, and I'll also put an initial on hand of 2. So in this case, I have 2 large muffin pans and 2 mini muffin pans. Then I'm going to connect this up to the kit, and then I'm going to double click on this kit, and I'm going to join the part and the fixture together. And it's important here to add the item to this block. So in this case, we're adding our Order A and our Order B. Now, once we've hooked that all together, they're going to go into a queue waiting to be processed. Now we want to actually perform work on this combination of parts and fixtures. In this case, this would represent our oven. We're just going to name this generically Do the Process Work. And in this case, we're going to say we have 3 ovens available. In this case, we're going to uncheck Allow All Items and add each part separately so that we can give them unique processing times. So with Order A, it's going to take in a processing time, and it's going to be triangular, and we're going to give it a minimum of 0.2 minutes, a mode of 0.8 minutes, and a maximum of 1.4 minutes. This oven bakes really quickly. For Order B, we're going to add that in. I'm going to set a minimum of 0.02, a mode of 0.11, and a maximum of 2. After our muffins are done baking, we need to separate the muffins from the baking pans. So we're going to drag in a split block here, and that split block is going to connect directly back to our fixture rack. Because the fixture rack had Allow All Items turned off, only the fixtures will go back into this spot. Now we'll add an exit block for Part A and Part B. We're going to turn off that Allow All Items and just add Part A and Part B. then you'll notice down here that if I come back to our fixture rack, you'll see that because allow all items is turned off and we've added fixture A and fixture B, then from this split, they are going to go to different blocks. Finally, we're going to introduce our part C, or our rolls. These are going to be without a fixture or a pan, and so we're going to add this demand for part C, no fixture required. We're going to remove that part A and then add in part C. And we're going to add an exponential distribution here for the time between our arrivals, and we're going to leave it as a mean of 1 minute. So now we're going to have an item that is going to take up some space in our oven. And you can see here, because this Q block has allow all items turned on, we're going to be able to easily process this item. Now I'm going to come into the activity block and add a part C. I'm going to change the processing time distribution here to a triangular distribution. It will have a minimum of 0.7, a mode of 1, and it will have a maximum of 1.3. Finally, I'll add an exit block that's going to catch all of our part C's. So I'll put exit for part C here. I'm going to turn off allow all items and just put part C. Part C doesn't require a split, so we want to peel that off ahead of time. So let's run the model. Now take a look at that here. We actually aren't having any items go through for part A and part B. You can see things building up in the queue as well as in the join parts and fixtures section. To debug this, let's look at the split block, which is the first block that doesn't have any items flowing through it. So in that split block, we can see here that we haven't chosen an item yet. So let's come down here and choose our items for order A and order B. And that tells the split block which items it's supposed to turn into its resulting parts. Now we're going to rerun the model again. And if I speed up our time here, we can see that both parts A and B are coming out at the end of the model, which is just what we want to see, and the model is now running properly. Also, part C is appearing in this exit block at the top and not leaking into the split block. In our join part and fixture block, there are some parts that are waiting for a fixture to be available. This represents muffin batter that's prepared, but still needs a pan before it can go into the oven. Finally, in our activity block, we can see at least 3 different blocks, representing the use of each of our 3 ovens, as well as the different colors, representing the muffins or bread rolls that are being baked and warmed. We can look further into the results of this simulation as well. Let's take a look at the queue leading into the oven. Click on Show Graph next to queue length. This graph shows how the items stacked up in the queue across the simulation. We can see that it builds up a bit, but overall, our process seems to be able to keep up. However, we do have a backlog in our kit block. Let's take a deeper look at that. If we open up the queue length graph here, notice how we were keeping up for a while, but eventually there started to be buildup as we waited for pans. So that's the muffin model, but the real value is in what you can test. When one product needs a shared tool and another doesn't, you can see whether your bottleneck is the oven, the pan, or the way work is scheduled. And while we use the kitchen example, this same pattern shows up everywhere. Molds and plastics, dies and stamping, test rigs and electronics, calibration stands, and other shared tools that limit how work flows. From here, you can start to ask real design questions. Should you buy another pan? Add another oven? Change the mix of what you're making? Those are the kinds of trade-offs this model is built to explore. That's the model. Now go experiment. Happy modeling!